Hello students, the properties of Z transforms I will continue. Fifth property, time domain convolution. Very important property, time domain convolution. I am going to write a statement. If x of n has a Z transform, if x of n has a Z transform x of z with ROC z belonging to the region Rx, and h of n has a Z transform h of z with the ROC z belonging to the region RH, then y of n equal to x of n convoluted with h of n will have a Z transform. Y of z is equal to x of z into h of z. ROC of y of z is z belonging to the region Rx intersected with z belonging to the region RH. What is very important over here is time domain convolution is converted into Z domain multiplication. Time domain convolution is converted into Z domain multiplication. And what happens to ROCs? The two individual ROCs get intersected to give the ROC of y of z. The proof I am going to do now. Proof. Y of z by definition is summation n equals minus infinity to plus infinity y of n into z to the power minus n. This implies y of z is equal to summation n equals minus infinity to plus infinity. What is y of n? X of n convoluted with h of n multiplied by z to the power minus n. Now we will apply the definition of convolution. Summation n equals minus infinity to plus infinity. Apply the definition of convolution. Summation k equals minus infinity to plus infinity. X of k into h of n minus k multiplied by z to the power minus n. Put n minus k equal to m and then interchange the summation orders, and then interchange the summation orders. That gives what? Y of z is equal to summation k equals minus infinity to plus infinity x of k. Summation with respect to n now gets converted to summation with respect to m. See, when n is minus infinity, m is minus infinity. When n is plus infinity, m is plus infinity. H of n minus k becomes what? H of m. Z to the power minus. What is n from here? N is nothing but m plus k. This in turn implies y of z is equal to summation k equals minus infinity to plus infinity x of k into z to the power minus k summation m equals minus infinity to plus infinity h of m into z to the power minus m. This summation gives you x of z. This summation gives you h of z. Hence the proof. ROC will be intersection of the ROCs of x of z and h of z. That means z belonging to the region Rx intersected with z belonging to the region RH. Hence the proof. Very important proof. This proof you have to write several times before the examination, and most of the times it is asked in the examination. And very important proof for the subsequent studies also, like digital signal processing, principles of communication, digital communication, etc. Next property, property 6. Time reversal property. Time reversal property. If x of n as Z transform x of Z, ROC Z belonging to the region Rx, then y of n equals x of minus n will have a Z transform. Y of Z is equal to x of Z to the power minus 1. ROC also changes. ROC says Z belonging to the region 1 by Rx. What is this property? In x of n, if you replace n by minus n, in x of Z, Z gets replaced by Z to the power minus 1. Also the ROC changes as indicated here. We will prove this. Proof. We know that y of Z by definition is summation n equals minus infinity to plus infinity y of n into Z to the power minus n. This implies y of Z equals summation n equals minus infinity to plus infinity. What is y of n? X of minus n into Z to the power minus n. Put minus n equal to m. When n equals minus infinity, what will be m? Plus infinity. When n is equal to plus infinity, what will be m? Minus infinity. So what happens after the substitution? Y of Z is equal to summation m equals plus infinity to minus infinity x of m into Z to the power m. We can interchange the summation limits, that will not affect the equation. So this becomes summation m equals minus infinity to plus infinity x of m into Z to the power m. So this I can write as summation m equals minus infinity to plus infinity x of m Z to the power minus 1 whole to the power minus m. So this is nothing but summation m equals minus infinity to plus infinity x of m into Z to the power minus m with Z replaced by Z to the power minus 1. So this represents the definition of Z transform of x of n. So what you get? You get x of Z with Z replaced by Z to the power minus 1. So you get x of Z to the power minus 1. What happens to ROC also we shall investigate. In this ROC also replace Z by Z to the power minus 1. Then you get ROC. This is ROC of y of Z. Replace Z by Z to the power minus 1. Z to the power minus 1 belongs to region Rx. Take reciprocals. Z belongs to the region 1 by Rx. Therefore, in x of n, if you replace n by minus n, in x of Z, Z gets replaced by Z to the power minus 1. In ROC also Z has to be replaced by Z to the power minus 1. That results in a change in the ROC given by Z belonging to the region 1 by Rx. These are some of the important properties which we have to learn. Next, Z transforms of, next topic, Z transforms of some useful sequences. Z transform of some useful sequences. First category, impulse sequences. Impulse sequences is the first category. In this subsection, let me take x of n is equal to delta of n. What is Z transform of this impulse? X of Z, we know that x of Z by definition summation n equals minus infinity to plus infinity x of n into Z to the power minus n. This implies x of Z is equal to summation n equals minus infinity to plus infinity delta of n into Z to the power minus n. Apply shifting property. Applying shifting property. Applying shifting property, we get. What is the shifting property? Z to the power minus n gets evaluated where this impulse is located. This impulse is located at n equal to 0. Therefore, we get x of z is equal to z to the power minus n at n equal to 0 equal to 1. Next, what is the ROC? See, x of z is 1. It is independent of z. Therefore, region of convergence is all z. That means this summation will converge when x of n equals delta of n in the entire z region. Second one, I am going to take x of n equal to delta of n minus n naught. N naught greater than 0. So what is x of z? X of z, we know that x of z by definition is summation n equals minus infinity to plus infinity x of n into z to the power minus n. This implies x of z is equal to summation n equals minus infinity to plus infinity delta of n minus n naught into z to the power minus n. Where this impulse is located at n minus n naught equal to 0. That means at n equal to n naught. So therefore in z to the power minus n, replace n by n naught. Put n equal to n naught. So you get z to the power minus n naught. Now where is the ROC? Z to the power minus n naught means 1 by z to the power n naught. Please see for what value of z, x of z becomes infinity. For what value of z, x of z becomes infinity. Z to the power minus n naught means 1 over z to the power n naught. When z equals 0, x of z becomes infinity. Therefore, avoid that value of z. Hence, ROC is mod z greater than 0. Mod z greater than 0 means we are avoiding the value z equal to 0. Why you should avoid z equal to 0? Because if you put z equal to 0, x of z becomes equal to infinity. This ROC is very important. Third one. X of n equals delta of n plus n naught. N naught greater than 0. That means this impulse is located at n equal to minus n naught. We know that x of z by definition is summation n equals minus infinity to plus infinity x of n into z to the power minus n. This implies x of z equals summation n equals minus infinity to plus infinity. What is x of n? Delta of n plus n naught into z to the power minus n. Apply shifting property. Z to the power minus n evaluated at n equal to minus n naught. So you get z to the power n naught. Now how to find the ROC? Please see for what value of z, x of z becomes infinity. When z is infinity to the power n naught is infinity. Therefore avoid z equal to infinity. Hence the ROC is mod z less than infinity. Hence the ROC is mod z less than infinity. To find the ROC for finite sequences like this, you have to see that for what value of z, x of z becomes infinity, avoid that value of z. Avoid that value of z. Fourth one. I take a sequence x of n is equal to delta of n plus delta of n minus 1 plus delta of n minus 2. This is same as x of n equals 1, 1, 1. This is the index arrow standing for the position n equal to 0. How will you find x of z? X of z by definition is summation n equals minus infinity to plus infinity x of n into z to the power minus n. This implies x of z equals summation n equals minus infinity to plus infinity delta of n plus delta of n minus 1 plus delta of n minus 2 multiplied by z to the power minus n. You have to apply shifting property 3 times. z to the power minus n gets evaluated at n equal to 0 because of this impulse. Z to the power minus n gets evaluated at n equal to 1. Z to the power minus n gets evaluated at n equal to 2. So this becomes 1 plus z to the power minus 1 plus z to the power minus 2. For what value of z, x of z becomes infinity? Z equal to 0. Avoid that value of z. ROC is mod z greater than 0. Because if z equals 0, x of z will be infinity. That value of z has to be avoided, which means ROC is mod z greater than 0. Fifth one, x of n equals delta of n plus n naught, delta of n plus 1 plus delta of n plus delta of n minus 1. This is same as x of n equals 1, 1, 1. The index arrow is here, n equal to 0. Now what is x of z? X of z equals summation n equals minus infinity to plus infinity delta of n plus 1 plus delta of n plus delta of n minus 1 multiplied by z to the power minus n. Again apply shifting property. Z to the power minus n gets evaluated at n equal to minus 1. Z to the power minus n gets evaluated at n equal to 0. Z to the power minus n gets evaluated at n equal to 1. So this becomes z to the power 1 plus 1 plus z to the power minus 1. Now you see, when z is 0, z to the power minus 1 becomes infinity. When z is infinity, again x of z becomes infinity. Therefore you have to avoid z equal to 0 and z equal to infinity. Hence the ROC is mod z greater than 0 less than infinity. ROC is mod z. Why mod? Because when z is 0, z to the power minus 1 becomes infinity. Therefore, z to the power minus 1, if it has to convert, mod z should be greater than 0. Z to the power 1 becomes infinity when z is infinity. That means if z to the power 1 has to give a finite value, mod z should be less than infinity. If we intersect these two, this means mod z should be greater than 0. This means mod z should be less than infinity. When you intersect both must be true, means mod z greater than 0, less than infinity. Thank you.